than this one. And so, you know, you've come to see me, and well, frankly, you may have picked wrong. Those guys are really good. But in this talk there's a lot in it. It's going to be, we don't have any kids in the crowd, right? This talk's going to be a lot like virgin sex. It's going to be over pretty quick. You're going to get something, but you're going to be missing out on the real experience. That's just how it's going to go. I've got a lot of content in here. I'm going to buzz through it, and that's okay. The whole point here is to kind of give you the idea of what you could do with graph theory, give you a little bit about the math, and about the tools you could use to do something with it, as well as the some of the ideas that I've been playing around with and some of the things I've been doing. But it's, you know, this is 2 hours of content crammed into an hour presentation being given in half an hour. And so it's going to be really interesting. So let's start out with who I am. And he just left. We were doing so well for like 10 seconds. Okay. I hope I don't have to do that between every single slide. We're going to do even less. So this is me. If you just came to get like the links and stuff, you can copy this down, you can leave, and you can actually go see those other people. But if you want to hear the cool stuff, stick around. The way I got into this is I like risk. I like doing risk. And I think we've all figured out, if we're doing security risk, that the context of the risk really defines what it is, right? And so it's important that what's going on. And we also started to figure out that it's not just this thing happens, right? You know, the attacker doesn't walk up. He walks up to his laptop, he hits enter, and like your database appears on pastebin, right? He has to do a couple of things. He has to go and, you know, scan your system, find the SQL injection, parse through the database, dump it out, post it. You know, it's kind of a set of things, kind of a path. And so, and you know, there's other things he could do. Maybe he goes and he does this attack, maybe he does this one. So the path kind of diverges and converges. And I was talking to a coworker, and he said, you know what, that sounds a lot like graph theory, this thing I did way back, you know, years ago. You should take a look at it and see if it'll work for you. And so also at the time I was doing threat modeling, and we've got these great Maltego graphs, right, that you've got all this information that's kind of linked together. I was trying to figure out how to apply that to the risks as well. And so it kind of led me to graph theory, and it's turned out to be a great thing. I use it all over the place in solving problems. So here's what I want you to get out of this talk. This is like the only thing I care about you getting, is that Infosec and graph theory is sexy defense. This is like the cool way to go defend your network. We're going to talk about graphs, kind of what they are. Then we're going to hit some of the math, and I'm going to speed through that like a freaking demon, because it's where I can steal time out of my presentation so we can talk about the cool stuff, which is the Infosec stuff at the end. We'll also hit on kind of the Lockheed Martin cyber kill chains and, you know, how to make that a little more generic and make use of it. And we'll also talk about some of the tools, so that like if you want to go home and do this and play around, you know, I want to give you what you need to just go jump right into it. You know, you can walk from here over to the tables outside, set up your laptop, and get started. Okay, so what's a graph? The fundamental spot, databases are about records and graphs are about relationships. And this is why it works so great for security, right? Because we're all about relationships. We're all about this IP is attached to this domain, or this thread is attached to this system, or this vulnerability is attached to this piece of software. It's all about the relationships that connect things. And so yet we're trying to cram all that data into relational databases that are just about records. Thing happened and a line popped out. And so graphs are really good for this. So graphs, or you can call them networks, are kind of two things. You have nodes and vertices, and you have edges, or lines. And when you put them together, you get a graph. And so I'm going to draw my charts. If I screw this up royally, let's just pretend I didn't. We'll all lie to other people that this went well. So you have nodes, and you connect them with edges. So it goes from, yeah, it's still fighting with, oh, it's the connection. Somewhere along the connection's bad. Let me exit out and pull it back up again. The AV guy left. Okay, well, we'll just push this over here. Am I getting it now? No. Okay, so you have nodes connected to edges, connected with edges. The nodes can be connected directionally, so kind of from Dave's head to Martin's feet, or they can be undirected, in which case there's no direction implied. Keep losing that monitor back and forth. You know what? Give me a second. I'm going to switch down to 1024 and see if that helps. Okay. Come on. Okay. And I'm going to use a bunch of kind of words that we all know, but I'm going to use them differently. So these are my definitions. If they're not your definitions, just pretend that they're your definitions for like the next 20 minutes. So here's all the math stuff. And this is a cool thing about graph theory, is this is an actual mathematical field. You can actually do stuff. And it's all been proven. This is a lot of what we do. We just kind of guess and we do our thing. Mathematicians have actually gone back and proven a lot of this stuff. So the first thing, and these are going to be little piece parts. We'll put them together later and explain why they're useful. Depth first searches. This is exactly what it means. You start up here, and as you search, you just go down. And obviously this goes this way. And so you're going down and over. Now here's the kind of the other way of doing it. Here we go over and then down. And who here has kind of looked at PageRank and any of that? We'll just assume a bunch of hands went up. So the way PageRank works, and this is what made Google really famous, is you use we call it a drunken walk. You start at a node, and then you just go to a node that's linked to that node. You can see this is directional. It has little arrows all over the place. And ultimately, the nodes that are most connected in the graph are going to be the ones that are most visited. Every once in a while, you make a random jump to something else. But you can see that, if you get to B, B has a lot of edges in, so B gets visited a lot. And C gets visited a lot because it's connected to B. A gets visited very little because it's off in the middle of nowhere. I'm going to let you take a picture of this one because the next one you're not going to want a picture of. Okay, and so because we've been doing a bunch of math, here's kind of the interlude. It's Hot Hacker and Ponytails. This is a God -1 from the Shmoo group, like a couple years ago, and my wife. I don't know why he was. Anyway. So another thing that you want to know is shortest paths. So you want to find the distance or the path to get from point A to point B. There's good algorithms to do that. Dijkstra's algorithm is one of those. And this is like, so let's say that, who here's done anything with the Lockheed Martin kill chains, read the paper, listened to the presentation yesterday on it. They talk about, there are various phases of an attack. And those phases, they go down. Oh, it's going to do it again to me? Yep. Let's see, will it come back up? No. Well, he didn't get talk when I mirrored it. So shortest paths let you find the distance between two nodes. And so let's say you had a path, we talked about kind of figuring out our risk by doing A, then B, then C, then D. If you had multiple paths through, you could find out what's the likely path my attackers are going to take by figuring out the probability that they do each one. You just make the assumption they're going to take the most likely thing. And so shortest path kind of helps you with that. Another concept is centrality, things that are central to your graph. They may be things that are in between the most paths. They may be things that are have the most edges in or out or closest to the most nodes. But you can find important things in your graph that way. You can also find communities. And these are all nice mathematical algorithms, and frankly, they're almost push button depending on what kind of tool you're using. This is a bipartite. In fact, this is actual real data. The orange are network devices. The purple are CIDR blocks. And they're linked by edges based on what CIDR blocks the network device has. And so, we can take this and we can make it a little simpler. We can go back and just link the CIDR blocks directly. So if these two network devices both talk to this CIDR block, we just put an edge between them. And if they talk to had two CIDR blocks and similar, we put kind of a number 2 on that edge. And that's called a bipartite to monopartite compression. And that's boring. The cool thing is when you go, you kind of relay it out, and then you go color it by community. This is data off of our corporate campus. And so the colored communities here are 2 of the buildings, the data center, and then the blue ones down the corner are the core routers. And this is without any knowledge of how the network was laid out. This is push button, and it tells me how my network's grouped up. And Bayesian math, should we spend a lot of time on this? No, this is a bad idea. This takes a lot of time. No one wants to hear a whole lot about this, but it's very useful. You can use it in a graph to predict, if these things up here are true or false, how likely is this thing to happen that's linked to them? Or you can use it the other way. You can say, I've got a bunch of things and I know they're interrelated, but I don't know how. And so what I'm going to do is go and collect samples, and it will tell me how the different things are linked. I'm getting good at this now. So kill chains and attack graphs. This is the Lockheed Martin thing. And they defined kind of a couple of steps that are common in attacks. They said, recon happens and these things, but you start looking in the black. Obviously, the squares are nodes and the lines are edges. And you really have a graph here, and so you can do all those graph things with it. But I kind of said, do we really need those different categories? Probably not. We can make it a little more generic. And I stole a bunch from a paper that we'll reference a little later on. And they said, instead of just actually having these steps, let's just call these things events, conditions, and we need to add in something else, which is the threat. That's the human user who makes decisions and ultimately has free will about what kind of attacks he does. And so we're going to build an attack path here. Dave wants to break into my Facebook and post our honeymoon photos. And so he's going to do a couple things to do that. He's going to try to break my Facebook password. But Facebook has brute forcing protection, right? And so, but he's still going to get in. He's going to do these things, and ultimately our bromance is going to be outed. This was our honeymoon. He's carrying me up to the honeymoon suite. It was a good time for me. I was very happy. So, but let's take a little more look at the path. So, we can see a couple things that pop out here. If our risk is likelihood and impact, we have likelihood, right? We've got vulnerabilities. Me having a weak password. We've got mitigations. Facebook has brute force protections. We've got a consequence. And so we can take the likelihood from this path, add it all up, and come to ultimately a risk. So he's got other options, though. And I'll show you in a second. So maybe he wants to avoid Facebook's ability to brute force my password. So what he does is he goes straight after my email. Right now I've got a stronger email password, and so the likelihood's going to change, but now there's not that mitigation of the brute force detection. And so he does something slightly differently, but kind of the end part of it's the same. He gets to the same conclusion. Or maybe he tries something completely different. He emails me a link to some malware, right? Kind of standard phishing stuff. Or, instead, we're going to change just 2 little things. He's going to take some of Mudge's awesome malware that Mudge is briefing right now, and he's going to mail that to me, just put it in the email and send it to me. And I'm still going to run it, and, bad things are going to happen. But, I said we were using 3 things, right? Events, consequences, or conditions, and threats. And I'm going to add one more into there, and that's attributes, because really, things like him wanting to embarrass me are not really a step. They're not an event. They're not a condition. They're not something that happens so much as a characteristic of Dave. And if Dave's going to send me some malware, he needs to have it. He needs to have gotten Raphael, and he can't really do that. He can't send it to me if he doesn't have it. So these are really attributes of Dave as a threat. And so we want to capture the attributes, and we can link them in, right? And so we can say, if Dave's the threat, wants to harm me, and has malware, then that next step is much more likely. If those things don't exist, then that step's not going to happen. Okay. So the graphs are cool. Let's get into some tools. Who's here Anyone use Maltego? Oh, good. Finally, hands. Yes. By the way, I'd like you all to cheer really loud because I'm thinking the camera can only get me. So the louder you cheer, the people on the camera will just assume that the room is like packed full. So, some other things in here. Gephi, if you're just getting started, download Gephi. It's a really good tool. It does almost all the things you want to do with Graph. It doesn't scale well. You get up to the 10s, 20s, 30,000 nodes, and it starts to work a little bit slower. But for anything you're going to want to do getting started, it's going to be great. As you start to get bigger and start to get more professional in your design, start looking at graph databases. Neo4j is a corporate one, but it's free to use for just kind of initial work. And it works really well. It's fun to use. It's got a great language to interface with. It's kind of like the SQL, but for graphs, and it works really well. If you want something open source, there's an open source project called OrientDB at orientdb.org, and the link will be in the last slide, so don't worry about it. Now, I like Python, so when I'm playing with this stuff, I use Python, and there's a great package that you can store graphs in Python called NetworkX. And to get the data out of my Neo4j database and into my NetworkX graph, I use a project called py2neo, and it's got just some easy bindings to get the data in and out. And so also, just so that it's not just like these are the things I play with, Academia has a lot of tools around this. And there's kind of these bigger, more professional standards like RDF and Sparkle. I don't use them a lot, and frankly, is anyone here experienced with RDF schemas? Okay, I need to talk to you afterwards because I, for the life, cannot figure out how to use them correctly. Okay. I really need help. But I got a feeling there's something there, but I'm not making it right now. But let's see. Okay, so demo time. Since everything else has worked, I'm sure this will go great. Okay. So at this point, Adrian, if this goes really poorly, just cut it out and say it was a technical failure. And this whole crowd is going to cheer later on, and we'll just cut to that as if, it went well. And I need all of you guys to lie for me, because no one will believe it if we don't back it up. So, yeah. Okay, so what we're going to do, if we can get this to show, is we're going to actually import data into a graph. We've got VM running Kali, and we're going to import, so those attack paths we did, right? We had 4 or 5 of them. They were kind of rows. I've got those in a CSV file as kind of like step, 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 step. And we're going to import those into a couple tools. We're going to import it into Neo4j using the same bindings we talked about. We're going to import it into Gephi using WebSockets. We're going to put it in a NetworkX file. And we're going to import it into UbiGraph, which is this nice 3D thing. Trinary Software is working on a much prettier 3D visualization for graphs, but it's not quite ready yet. So just so you can see, here's, if we can get it to click. Oh, it would help if I unpaused it. So this is Neo4j's web API, or web interface. This is Gephi. And this is a Python script that is horribly washed out. I think this will still show. And what this does is it just reads the CSV file, and it's got nice little functions that import the data. And by the way, if you all want to get this is up on the GitHub already. This is all there for you guys to try out. And so if you want to give this stuff a try or use this as kind of a framework to build whatever you want to build, by all means, go ahead. And so let's go up here and see if this runs. This is the time where talks fail, I think. Demo time. But we've already done all of our failure, right? Okay, so it's starting the import. It takes a little time to kind of build up the graphs, make the connections. And pretty soon we start to see our nodes popping in here. And these are popping in 3D. We can rotate them around, and you can kind of see that they're all labeled. And they're, of course, going in a line because that's how we had defined our attack path. You can kind of see another line building down to the bottom now, and you can see actually that it connects up because the last steps are all kind of the same. And I'll turn the labels off so it's more obvious what's happening here. Right? And now we've got 3 paths. And then we've got another path, and it pops in right along there. And then we're going to add in the attributes at the end. And so now we've got our attack graph in 3D. I am not above whoring for claps. And more so, it's not just in 3D. This is kind of your pretty, wonderful, whatever. We also have it in the other tools where it's much more usable. So no, you can't see this. This is the joys of Gephi, but it is there. And we can lay it out, but it'll look similar to what we laid out before. If we go back and look at Neo4j, we can do a search, and there's a bunch of nodes in the graph. I've limited it to 5. And Neo4j's got some nice layout properties. You can click things, and it lays them out, and you can click more, and it starts to do a nice layout stuff, but it doesn't scale very well either, unfortunately. And if we were to look here, there'd be a file written here. So this is as much about the demo as it's more about giving you guys a tool that you can play around with, something that you can import some data with, get it into your system. So, okay. So, but that's not great for explaining this to your leadership, right? Your leadership doesn't care about pretty 3D stuff. But you can lay these attack paths out in something that managers can understand. You can define actors. You can define their motives, their consequences. And you can lay out kind of that path as a narrative. This is a great way for getting your leadership to kind of understand and accept what you're doing. It's kind of that glue between what you're doing, on the backside and doing in your graph and all the fancy things, and what your leadership, ultimately understands. And one of the cool things is we're really not just doing Infosec stuff here. We're predicting how humans will behave by applying those attributes to our path. And so this is kind of a little bit like psychohistory, right? Figuring out under given circumstances, what will people do? So let's go into the Infosec stuff, which I've got 5 minutes, 10 minutes? Well, the proctor's not in the room, so I've got as much time as I want. So, okay, we can make pretty pictures, right? Especially like this one. These are different views of my network. Some of them are the organizational, some of them are NetFlow data, some of them are hierarchical. This one is what talks to what in my data center. And it's very pretty. Little washed out, but this one went over really well with leadership. Anyone want to guess what the yellow thing is that talks to all that tons of other stuff? The NAS. In the data center, in this picture, it talks to more than anything else. And I've gotten more data into this. And now the most talked to thing is the pack file server. Because we've got multiple domain controllers all over the place, but we only got the one pack file server. So risk management. This is the same thing we did with the attack paths. This is actually laid out in Gephi, and is that 3D, what was 3D laid out. And so we can kind of see the different paths through. And we could do cool things, right? We could put vulnerabilities in, we could put mitigations in, we could recalculate the risk. We can figure out what paths attackers will take. Will they go A, B, C, D, E, F? Will they go over this way? Oh yeah, I could draw on my slides. Why am I doing it here? They could go this way, they can go this way. We can figure out what they're most likely to do, which ones they're most likely to do. We can also go out and figure out the overall likelihood. What's the chance that an attacker will make it down to this last spot down here, given the entire graph? And this is kind of the cool stuff that Bayesian math does. We can do threat modeling, right? This is just standard Maltego stuff. But, and this solves a problem that we've probably heard come up in some of the other talks. Like one of the other talks they were talking about, who uses the MITRE formats or open IOCs? And it's like, we all know about them, but we don't really use them. There's these great formats for kind of defining what's happening on our network. Things like OpenIOCs, the Verizon Incident Database, STIX, Cybox, which are kind of the MITRE things. There's formats, or the data constructs form, JSON, XML, just straight database records or log records. But it's hard to get them back and forth, right? It's hard to share them between people, or even to get them to interoperate. If you take them and represent them as a graph, now it's much easier. Because if in a record you have this record, and now you've got to match this record fits this portion of this query over here. In a graph, you just have a single node that says this is an IP address, and hey, I found the same IP address node over here, so let's just make them one node. And they inherit all the links between them. And so now you're linking together your data regardless of the construct. Whether it was JSON that you originally originated from, or an open IOC, you can link that data together. And the graph doesn't care. It just knows that this is the same type of thing as this over here. And you can still retain your original formats, your open IOCs, your sticks, constructs, and such. Intrusion detection. So each one of these steps, right, was something happening. Like one of these may have been someone hitting the web server. And when we hit the web server, right, we generate a log file, or we generate a log record. And so let's say this is that log record that hits the website. And let's say this is an IP for it. Well, let's say this next thing is maybe our IDS saying we have a weird SQL query. And it generates another record. And let's say the IPs are the same. So now we see those things are linked. And let's say we have another construct that's linked to this third one down here, and it's got another one, it's got the same IP. And what we can see is we've got a linkage. So, yellow is probably not a good choice for these sides. Let's go with purple. That's a much better choice. So we've got the IP, and it didn't do it. We've got the IPs right there. And we've got the path progressing this way. So what you can see in your data now is you can see that one of my attack paths is starting to happen. So they haven't made it down to the consequence yet, but we can see where this is going. We can actually detect the attack before it completes. And so what about incident investigation? You've got all incidents, and you start with some record. Well, you can go back and go look for the other constructs. Use your construct to search your log data, your events, all that. And so you pull in some more records, and you can link them into your graph. So now you have some other things to search on, and you link those into your graph. You find some more, and all of a sudden you've put together an entire record of your incident. Just by searching back through your logs for your graph constructs. And you can do it for documenting your incident too, because all these different records have timestamps with them. And something like Gephi will play your graph back over time, right? It'll say this node happened at this time, or these nodes happened at this time. And ultimately it will play out, and you can actually watch the incident happen based on your logs through a graph. So now you have a visual representation of that event. And so what am I doing? Minions. I love my minions. I have, and this is something also on the GitHub. What I like to do is I like to write little things that go and do little things through my graph, right? I've got my tall minion, which does my depth first search. I've got my short minion, which does my breadth first search. And I've got my drunk minion. He's the purple one over there. My drunk minion goes and just does the random walk, the Google PageRank walk. And so they're just walking around my graph doing things, right? They find a node that isn't populated. And so they go and they go grab some data out of maybe the NetFlow or some other thing and populate it. You could look for anything. You could do anything. You could update your data. You could go and grab more data and put it into the graph. You could refine it. And ultimately, the nice thing is because your graph doesn't have to be completely up to date at any given time. You can just kind of continuously work through it. So I am going to run through the rest of this. And I want you guys to go and download and build your own minions. Once you've got your graph, you can build your own minions to do whatever you want on it. We talked about data sharing. So one of the things I'm working on is building out some modules to translate between JSON and XML and stuff so that you can get data in and out of your graph. Now, one of the cooler things I'm doing, it's called Moray. And what I've done is I've taken my graph database and I've put a pub sub on the front of it. And so what we do is you have an IDS client and it sees an event, right? And so it passes it in. And it gets sent out over the pub sub, say to the log searching client. So the log search client gets that, says, hey, I see records in here, I see IPs and things that I can go look in my logs for. And it goes in and finds all the logs on your Apache server as such that are related to it. Oh, I made it so far without that happening. Okay. I'll bring it back in 1 second. And so now the log server passes that data back in. And all the other things get it back again. And so now what you can see is you don't have to have all your data stored in your SIM, right? It doesn't have to be in one place. It can be all over your network, and you can just go get it when you need it. Now, from a visualization standpoint, here are a couple tools. These are all kind of web-based and JavaScript-based, except for the one down there. That's a movie. I really like the interface, so if someone could build it, I'd really appreciate it. It's really cool. And the other thing we can do is, let's say you've got a security proxy, right? And it gets connection. It's not really sure whether to let this guy in or not. So what this guy does is the security proxy goes and it asks the database. It says, here's a construct that represents this connection. It takes all the characteristics it can, passes in the database. So we talked about breadth first searches. So it connects it to the database and then does a breadth first search from each of those nodes and goes, okay, what's close to it in my attack graph? Were there threats close to those nodes? Were there consequences close? And so you can actually build a reputation based on the data it gets back from the graph. And so you didn't need to know that this IP is always malicious or this thing is always malicious. In fact, it may be a combination of those characteristics that gets passed back up into the proxy, and the proxy ultimately makes a recommendation. And there's some other ideas. And by the way, these tools are things that I'm working on. What I'm doing right now is the network analysis. I'm taking a huge network and using my graph database to go and figure out how to parse it up, how to categorize nodes, how to figure out what nodes are related to other ones, where to put my boundaries. Doing a lot of math around that, but you could also do this offensively, right? You could build a attack graph in the offensive sense and say, I want to do this, 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 and this, and then say, okay, when the predecessor nodes exist, then do this. And you could automate your attacks, right? We can just do push-button pen tests, or better yet, replayable pen tests. So we can actually repeat what we did. In fact, maybe we can use it to train our security people, right? We play it for them slow so they see it happen. Then we play it at full speed. Then we play it again so they can practice defending against it. So, time-wise, okay, I'm going to just skip through the summary. It's really funny, and it's based off of Wendy's DEFCON talk, but I just don't have any time for it. Big data, cloud. We'll stop at cyber. No one's playing the drinking game. That's kind of depressing. So, okay, hopefully if you've gotten anything out of this, it's that graph theory and Infosec can come together and make a really awesome defense. This is something you can use to go and figure out how to do the things you want, figure out the relationship between things, and ultimately kind of have fun with your defense and make your defense better. Because when I can use my graphs to work with you and you and you, now we're ahead of the offense, right? We can win against them. So in the end, here's the slide with all the links. The QR code just goes to the website. It's got more of the links on it. If you don't trust me, then you probably shouldn't have been in here for the rest of the talk, because I may just be lying off my ass to you. Oh, wonderful. The room actually did fill up. That's awesome. The talk after me must be great. So, thank you.